Have you ever wondered if humans could live on Mars? It's a question that has piqued the curiosity of scientists and space enthusiasts alike. The red planet, with its harsh environmental conditions, presents significant challenges to human habitation. Yet, in the face of these challenges, researchers and space agencies are devising innovative strategies. From developing technologies to produce oxygen, to designing radiation-shielded habitats, and even considering genetically modified crops for agriculture. So let's dive in and explore the challenges and strategies for living on Mars. The thin carbon dioxide-rich atmosphere of Mars is a significant challenge for human habitation. Imagine trying to take a breath and all you get is a lungful of carbon dioxide. Not ideal, right? This is the stark reality of the Martian atmosphere. It's like being stuck in a room filled with smoke, not a whiff of oxygen in sight. But fear not, for we humans are quite ingenious when it comes to overcoming obstacles. Researchers are developing technologies to produce oxygen on Mars. One such strategy involves extracting oxygen from the Martian soil, known as regolith. This soil contains oxides that, when heated, release oxygen. It's like squeezing water from a stone, except we're doing it with oxygen on another planet. Another approach could involve bringing oxygen supplies from Earth. This would be a bit like packing a suitcase full of air before going on a long trip. It's a fascinating challenge, but remember this. Creating a breathable environment on Mars is a challenge, but not an impossible one. Radiation, a silent yet deadly threat on Mars, poses a significant challenge for human life. The red planet, unlike our home, lacks a thick atmosphere and a strong magnetic field. As a result, Mars is continually exposed to higher levels of cosmic and solar radiation. This constant bombardment could lead to severe health hazards for potential Martian dwellers, including an increased risk of cancer. However, our ingenuity has a knack for turning challenges into opportunities. To counteract this invisible enemy, we could design habitats with built-in radiation shielding. These structures would act as our personal fortresses, safeguarding us from harmful radiation. Alternatively, we could go underground, constructing habitats beneath the Martian soil. Here, the natural layers of rock and soil would serve as an efficient shield against radiation. Radiation may be a formidable adversary, but it's not insurmountable. With adequate shielding and careful planning, humans could potentially survive the radiation levels on Mars. The extreme temperature variations on Mars present another formidable challenge. Mars isn't exactly a tropical paradise. With an average temperature hovering around a bone-chilling -80 degrees Celsius, it's more like the coldest winter night you could possibly imagine, but all the time. This is due to Mars's thin atmosphere, which is incapable of retaining heat. But as with every challenge comes an opportunity for human ingenuity to shine. To combat these extremes, we could create insulated habitats with advanced heating systems, a bit like turning your home into a space-age thermos flask. It's a bit more complex than that, of course, but the idea is to maintain a consistent, livable temperature regardless of the Martian weather outside. Alternatively, we could take a page out of nature's book and go underground. Subterranean structures would offer natural temperature regulation, providing a respite from the bitter cold above. Despite the harsh temperatures, technology could provide us with the warmth and comfort needed for survival on Mars. Water, resources, and food, the vital ingredients for life, pose significant challenges on Mars. The red planet, with its cold, dry, and barren landscape, is a far cry from the lush, water-rich environment we call home. Liquid water, an essential element for life as we know it, is scarce on the Martian surface. But where there's a will, there's a way. And scientists are exploring methods to extract and purify water from the Martian soil and subsurface ice. It's a bit like mining for gold, but in this case the treasure is clear, drinkable water. And water isn't the only resource in short supply. The materials we need to build, fuel, and sustain a Martian colony are largely absent. This is where the concept of in situ resource utilization, or ISRU, comes into play. ISRU is the practice of using materials found on Mars to support human habitation, rather than lugging everything we need from Earth. This might involve recycling waste, manufacturing fuel from Martian carbon dioxide, or even creating bricks from Martian soil. Now let's talk about food. The Martian soil, or regolith, lacks essential nutrients for traditional agriculture. It's a bit like trying to grow a lush garden in a sandbox, but humans are resourceful, and we're exploring innovative ways to bring the green to the red planet. Hydroponic or aeroponic systems, which grow plants in nutrient-rich solutions rather than soil, could let us cultivate crops in controlled environments. and scientists are even considering genetically modified crops that could thrive in Martian conditions. Imagine Martian tomatoes that taste just as juicy as those from your local farmer's market. Sustaining life on Mars is no small task. It's like planning a camping trip, but the journey is several million miles. You can't breathe the air, and there's no corner store if you forget something. But with a combination of advanced technologies and good old-fashioned human ingenuity, we're developing ways to extract, recycle, and grow what we need to survive. Though Mars is a harsh and barren planet, innovative technologies could help us extract, recycle, and grow what we need to survive. Gravity and infrastructure, two fundamental aspects of life on Earth, present unique challenges on Mars. Now, let's talk about gravity. It's something we take for granted here on Earth. But on Mars, gravity is only about 38% of what we're used to. This reduced gravity might seem like a fun change at first, but it could have long-term health effects on our bodies. Bone density loss, muscle atrophy, and cardiovascular changes are just some of the potential risks. To counteract these, researchers are studying the impacts of reduced gravity, exploring possible countermeasures, and even considering the development of artificial gravity technologies. Then, there's the matter of infrastructure. Imagine a road trip from New York to Los Angeles, but in space, and it takes about 6 to 9 months. That's the journey to Mars. And once we get there, we need a place to live and work. This calls for the development of efficient spacecraft for the long journey and the establishment of a permanent base on Mars. These bases would not only provide shelter, but also facilities for research, living, and resource utilization. Building this infrastructure won't be easy. It requires advanced technologies, careful planning, and a huge investment of resources. But remember, we're talking about making a home on a different planet. Despite the challenges with ongoing research and technological advancements, humans could one day call Mars home. Living on Mars, a concept once confined to the realm of science fiction, is now a subject of serious scientific study. From generating oxygen and shielding radiation to managing extreme temperatures and finding water, each challenge presents an opportunity for innovation. We're exploring possibilities for agriculture in Martian soil, understanding the impacts of reduced gravity, and envisioning a sustainable Martian infrastructure. While the challenges are significant, the strategies and technologies being developed give us hope that one day, humans may indeed live on Mars.